this can be little bit intimidating. Now we have a chord that is being dropped, and exactly at this point there is a tangent. So the chord is making a point of contact. Now we have a completion here. And a triangle is created. Now there is also another tangent, and so we have a point of contact of the two tangents. So let this be T1, let this be T2, let this be the point P, let this be O, and let this be some A. Now we are given this angle to be as, say, x degrees, and this angle to be y degrees. They are asking us to find what is x positive y. This angle is given to be as 30 degrees. Okay. Now clearly you have the tangents intersecting at this point P, right? Now what we can do to solve the question is, we have to draw the radius to hit the tangent T1. So by the tangent radius theorem, the angle made by the radii with the tangent is 90 degree. This angle is 90 degree. I'm going to draw another line from the radius, from the point of the center point of the circle to T2. So this is also a radii. So you have R1 and this is also R1. This will also make an angle of 90 degree. Now what I wish to do is, I would like to know this angle. Let me take it as theta. Now this is actually a four-sided figure, 1, 2, 3 and 4. It's a quadrilateral. So if I were to use the property from quadrilateral, the sum of the angles should be equal to 360. So this angle is 90, this angle is theta, this angle is 90, right? And this angle is 30 degrees. All of these will add it up to 360 degree. So 90, 90, 180, 180 added with 30, and I have a theta there, is equal to 360. So let me use the space here. So this is going to give me 210 degrees. So you have 360 minus 210. What is this? This is nothing but theta. So theta is going to be equal to 150 degrees, right? So 360 degrees minus 210 gives me 150 degrees. So theta is 150 degrees. Now you might be asking me why that theta value is important. Now by the alternate segment theorem, what do we know by this theorem? Angle created by this chord with a tangent is the same as the angle subtended by the chord at the circumference, right? But in this case we are going to be considering the angle subtended by the chord at the center. So what did we learn in the previous theorem? the angle subtended by the chord is actually twice the angle made by the chord with a tangent. So that means this angle x that we are talking about is actually equal to this, or I would say 2 times x. This is the best way. 2 times of x, the angle created by the chord with a tangent, will be equal to theta. But what is theta? Theta is 150 degrees. So what is x? X is nothing but 150 divided by 2. So which means x is equal to what? 75 degrees. So we are getting x to be as 75 degrees. So the angle created by the chord with the tangent is 75 will be the same as the angle subtended by the chord with at the circumference, right? So it's actually the opposite side only the subtend is taking place. So y will also be equal to 75. So they are asking what is x positive y. So therefore x added with y is going to be 75 added with 75 will be equal to 150 degrees. Okay, so that is the solution for this lovely question.